All right, so we are still talking about NIST documentation, special publication, network of things. So there they describe 5 primitives. We've talked about first 2, sensors and aggregators. The remaining 3 are communication channel, external utility, and decision trigger. So let's focus on communication channel. A communication channel is a medium by which data is transmitted, for example, physical via USB, wireless, or wired, verbal, etc. Communication channels move data between computing, sensing, and actuation. Since data is the blood of network of things, communication channels are the veins and the arteries. As data moves to and from intermediate events at different snapshots in time, communication channels will have a physical or virtual aspect to them, or both. Protocols and associated implementations provide a virtual dimension. Wires provide a physical dimension. Communication channel data flow may be unidirectional or bidirectional. This is important because sometimes you only receive data from sensors, but sometimes you send data back. And depending on what you send, their behavior might change. So unidirectional or bidirectional depends on the context and your setting. There are a number of conditions where an aggregator might query more advanced sensors or potentially recalibrate them in some way. For example, request more observations per time intervals. No standardized communication channel protocol is assumed. A specific network of things may have multiple communication protocols between different entities, and this is most of the time the case because maybe your sensors use Bluetooth or Zigbee, but from aggregators to aggregators you use maybe Wi-Fi. Okay, so protocols change. Communication channels may be wireless, and nowadays almost everything is wireless, right? Communication channels may be an offering, service, or product from third-party vendors. By the way, sometimes you even use GSM communication in some sensors, depending on your setting, because maybe you need a long range of communication, right? So people still use 2G or 3G in these settings. Communication channel trustworthiness may make sensors appear to be failing when actually the communication channel is failing. This is also important. Sometimes you don't know where the problem lies. Communication channels can experience disturbances, delays, and interruptions. Even weather conditions, might affect this. Redundancy can improve communication channel reliability. There may be more than one distinct communication channel between a computing primitive and a sensing primitive. Performance and availability of communication channels will greatly impact any network of things that has time to decision requirement, because if your decisions depends on time and if you need fast communication, performance of the channel is important. Of course, security and reliability are concerns for communication channels. So you might ask why these sentences are important, because actually this means where we are going to focus next, because it says that security is important here. This is where we actually talk about lightweight algorithms to be put here, okay? External utility. An eUtility, this is the 4th primitive, by the way, that was all about communication channel. An eUtility is a software or hardware product or service. The current definition of eUtility is deliberately broad to allow for unforeseen future services and products. So this is the thing when an area emerges in a fast way. So maybe in the future the definition will be different. eUtilities execute processes or feed data into the overall workflow. eUtilities could be acquired off the shelf from third parties. eUtilities may include databases, mobile devices, miscellaneous software or hardware systems, clouds, computers, CPUs, etc. The eUtility primitive can be subdivided and probably should be decomposed to make this model less abstract. And nowadays, everybody prefers cloud, by the way. So this also raises another question. If you are performing operations on the cloud, this means that you are sharing data with the cloud service. Again, you are losing confidentiality there. So more measures has to be taken in order to have more confidentiality. So encryption also plays a more important role in this scenario. I mean, assuming that the clouds will not, use your data is a very optimistic case, okay? eUtilities such as clouds provide computing power that aggregators may not have. Amazon Web Services and so on are very famous in that respect. And by the way, they have many confidentiality solutions in Amazon Web Services or similar services. So you can have encryption, decryption, etc. So most of the time, if you do everything correct, no third party can actually reach your data. But of course, if you are using that service, they can see your data, unless you are putting every data in an encrypted way. But in that scenario, you cannot perform operation on them, right? If you are using classical encryptions like block ciphers and so on. Otherwise, you can use homomorphic encryption solutions, but this would be really, time-consuming and, requires a lot of resources. So you cannot work on big data, but also use it full as if it is a full homomorphic encryption and so on. A human may be viewed as an external utility. A human is sometimes considered as a thing in public discourse related to IoT, but again, not in this lecture or document. Data supplied by an eUtility may be weighted. An eUtility may be counterfeit. Non-human eUtilities may have device IDs, which may be crucial for identification and authentication. Again, security and reliability are concerns for all eUtilities. As I mentioned, even if you're storing data at the cloud, then you have to consider about different security solutions. All right, let's move on to final primitive, the decision trigger. A decision trigger creates the final results needed to satisfy the purpose, specification, and requirements of a specific network of things. A decision trigger is a conditional expression that triggers an action. A decision trigger's outputs can control actuators and transactions. Decision triggers abstractly define the end purpose of a network of things. A network of things may or may not control an actuator via decision trigger. A decision may have a binary output, but there will also be situations where the output of a decision trigger is a non-discrete output. In other words, a continuum of output values. A decision trigger may have a built-in adaptation capability as the environment element changes. Again, by environment, we can mean anything, the temperature and so on. So your decisions may depend on those different parameters, okay? A decision trigger will likely have a corresponding virtual implementation, in other words, code. Of course, it should be securely coded, which is not an easy task, by the way, right? A decision trigger may have a unique owner. Decision triggers may be acquired off the shelf or homegrown. Decision triggers are executed at specific times or may execute continuously as new data becomes available. Again, it depends on the context. Decision trigger results may be predictions. Analytics could be implemented within decision triggers. However, analytics could also be implemented within aggregators that are executed by eUtilities. If a decision trigger feeds data signals into an actuator, then the actuator may be considered as an eUtility if the actuator feeds data back into the network of things. Also, an actuator can and often should be considered as a component of the environment element. A decision trigger may feed its output back into network of things, creating a feedback loop. It is fair to view a decision trigger as an if-then rule, although they will not all have this form. Yes, not everything is like if-then rule, right? Depends on the context. The workflow up to decision trigger execution may be partially parallelizable because you will be using different actuators maybe, and maybe the data can be processed in a parallelizable way. Failure to execute decisions triggers at time Tx may occur due to tardy data collection, inhibited sensors or eUtilities, inhibited communication channels, low performance aggregators, and a variety of other subsystem failure modes. Economics and costs can play a role in the quality of the decision triggers output. There may be intermediate decision triggers at any point in a network of things workflow. Decision triggers act similarly to aggregators and can be viewed as a special case of aggregator. Security is a concern for decision triggers, malware, or general defects. Other possibilities here might be indirect manipulation of input values to the trigger by tampering with or restricting the input values. So here, actually, what we mean is that maybe your data is poisoned. Maybe they are fake devices putting fake data, or maybe the sensors are really yours, but they are deliberately malfunctioned or something, so they're sending wrong data. Finally, reliability is a concern for decision triggers. Decision triggers could be inconsistent, self-contradictory, and incomplete. Understanding how bad data propagates to affect decision triggers is paramount. Failure to execute decision triggers at time tx may have undesired consequences, because you're collecting every data to make a decision, and if your decision is wrong, it might have a catastrophic result, right?